Welcome to Cpp.chat, a multi-byte look at what's going on in the world of C++, chatting with guests from the community. But before we get to this week's set of characters, John has a disclaimer to read.
Actually, Phil, with this many characters, I think we need to have two disclaimers. So that's what we're going to have today. The first is, all characters appearing in this work are fictitious. Any resemblance to real persons, living or dead, are purely coincidental. The second disclaimer is, this is a draft document which may be updated, replaced, or superseded by other documents at any time. Publication does not imply endorsement by the Unicode Consortium. This is not a stable document. It is inappropriate to cite this document other than a work in progress. All right, so we've got a little bit of a different format today, and it's simply because of the number of, as I said earlier, characters. We've got several people from SG16. We will be asking them what SG16 is and what their goal is and why we're trying to figure that out. But first, Phil, I want to share my really lame Unicode joke, right? Is everybody ready for this? Okay. A Unicode character walks into a bar. Bartender says, "Why the long face?" Unicode character says, "I have a parody error." Bartender says, "Well, you looked a bit off."
Yeah.
Okay. All right. Well, there we go. So we've set a low bar. Everything from here on is going to be better. All right. Actually, one of the things that we have on StreamYard is we have a limit of only 6 people can be here. So we actually, there's actually 6 of us. So I think Phil's going to kind of excuse himself after we go through the news. Is that the idea, Phil? And
yeah, that's right. We've got Steve Downey off to the side in the waiting room.
Okay.
He's going to join us for the rest of the show.
And then, but if Phil has a comment, he'll pop back in to ask questions or make comments or whatever. So let's talk a little bit about news. We're going to get through this so that we can get into the talk. One of the things I wanted to talk about was Cpp.cast. This morning I listened to Cpp.cast with Barry Revson, I think, is that to say his name? It was a great show. It's always a great show. I always say that about Cpp.cast. I always watch, listen. And this time, it just came out this morning, so I was listening already. Normally, I can listen while I'm driving or, somewhat engaged with doing chores or something like that. But this one, I think I'm going to have to listen to it again and pay attention to what playing with the compiler as they're talking, because he covered a lot of good stuff with some corner cases and interesting stuff. So I really want to make sure everybody listens to that. What else is going on, Phil?
Well, we usually do a bit of a conference roundup.
Yeah.
And I sort of alluded to this in the last episode, actually, but the conference is starting to be impacted by the ongoing coronavirus crises, really, that we have at the moment worldwide. I'm not sure still of any C++ conferences that have actually been cancelled, although a number of other bigger events have been. But certainly all of the conference organisers that I know are thinking about what the impact's going to be, plan Bs, and what else can happen. The ACCU is coming up in a couple of weeks, and they've put out a statement saying that they are planning to go ahead as originally planned. But I know some speakers have had to pull out already, some sponsors as well. And if the situation gets worse, then they may actually consider something more online based. And I know some other conferences are thinking the same thing. So for myself, C++ on C is off in June. That's still planned to go ahead at the moment, but obviously keeping a very close eye on that situation. And I think you're in a similar position, aren't you, John?
That's right. Although I'm not if we cancel it, we cancel it. I don't think we're doing that, but we're not going to do online. I don't even know how that would work exactly. I am full speed ahead with both this and CPPCon. Of course, CPPCon being several months out, we're not as concerned about that. One of the things I would say to anyone listening is, if you've been thinking maybe you want to speak at a conference, this might be the year, because some of the conference are actually waitlisting speakers. So even if you don't necessarily get accepted, you may still end up being there, because a lot of speakers are canceling, not because they don't want to come, but because their company is saying, nope, you can't go. And this is frustrating to both them and to the organizers. But this is one of the things that organizers are starting to look at, which we, generally speaking, we don't waitlist speakers. It's kind of tough to say to somebody, well, that talk you were going to prepare, can you do that in about a week? Because somebody bailed on us. That doesn't work too well, but that may be the reality this year. So if you've been thinking about speaking at a conference, this might be the year to apply.
And if you do go to a conference, whether as a speaker or as an attendee, obviously people have different opinions about how serious they think this whole thing is, but it doesn't hurt to really pay attention to basic hygiene, washing hands,
Sure.
Not too much contact with people. It's just common sense, really.
So we did have a sponsor that wanted to know, could they sponsor masks with their logo? It turns out that people are saying the masks don't really help at all with coronavirus. What I recommended was that they get one of those funnels that you put on dogs and cats when they've had surgery so that we don't touch our face, right? And we'll just walk around with funnels. All right.
I think if the banks actually sponsored those masks, they'll really be putting their money where their mouths are.
No. All right, it's getting bad. It's getting bad. Anything else we need to touch on before we start talking about SG16 and what all our characters are gathered for?
I think with so many people on, we should really get into the meat of the show.
Okay. All right.
So I'm going to duck off and let Steve join.
All right. I'm not sure exactly where to start with this, but what I want to do is ask Corentin to give us a little bit of the background on what Unicode is about. I suspect most professional programmers today have touched it in some way, but a lot of people don't work with text a lot. So let's start at the beginning.
Okay. So
hang on 1 second first. I forgot. I haven't introduced you, and I don't want to introduce. I hate when we do a whole bunch of introductions. So I want you to introduce yourself, and we'll do introductions kind of as you say something. How about that?
I'm really bad at doing my own biography, so I would just say that I'm a freelance C++ developer. I've been doing C++ for more than a decade, I think. I'm a committee member, and I participate to a lot of study groups, including Unicode, Library Evolution, tooling, and so forth. So Unicode, people have been writing for 5,000 years. Or so. We have invented writing maybe 5, 6 times. We don't really know actually how writing developed, for example, in China. And this writing system has been evolving unchecked for 5,000 years ago. And at some point we decided we want to put that in computers, right? And it turns out that it's really complicated to basically try to encode the entire human cultures into a binary system. But it's basically what Unicode tries to do, right? So Unicode is both a way to encode characters. So try to give basically each existing character a number. Like say the letter A is number 65 and the Chinese character is number 1,000 and something, right? And at the same time, they're trying to encode every possible local that exists. So every way to format number, every way to say what the week names are, month names, and so forth. So it's really trying to encode many things about culture. And so when people
wait a minute, are you saying there's now a Unicode character for the days of weeks and
no, but they're like a database of translation that is related to local, but Unicode does also that, right? So Unicode is both characters, algorithm tied to this character, right? So you have like uppercasing, lowercasing, which exists for Latin alphabet, normalization, which we can maybe talk later. I don't know. So all these algorithms, this character, and they also have a database of local information. So Unicode is not just a Unicode standard. They have all these different things they're trying to do. And so trying to digitalize local characters and the things that most people are most interested about, they also do emojis. And that takes a lot of time to do emojis, but they do that. But their principal mission is to try to encode all languages and all characters. And so that has like, it's important for people to that are using this character today, right? But they're also trying to digitalize their language, their characters, so people can do research and literature and research paper about old Egyptian or some older civilization. And it also helps small culture be preserved, right? Because if people don't have like a computer they can use in their language, that language dies eventually. So Unicode try to preserve all of that culture for hopefully for eternity.
So, those of us who have lots of gray hair, and I have lots of gray hair, remember what it was like pre-Unicode, right? I mean, it used to be that the way we did this was we had some kind of encoding for every kind of string, and it's some different encoding. And if you wanted to translate between one encoding and another, it's possible characters just weren't there, and you would just lose data. To make matters worse, the way the Windows worked is they had something called a code page. Wasn't exactly an encoding, but it was kind of. And this is just a mess. So I think Unicode was kind of started by three guys, right? It was one guy at Apple and one guy at Sun and something like that. One guy at IBM.
I think at the time they were trying to do something for the Apple II computer in Japan. That was the starting point of that. Yeah. And it was people from Apple, I think, Xerox, because Xerox had a previous encoding that was somewhat universal. And maybe at some point people are Adobe, I'm not sure about the early years, but that's like between 85 and 89, basically.
So we have huge buy-in of a single encoding standard, right? And that was what Unicode was specific. That's why its name is Uni, right? Yeah. It's like the famous XKCD, cartoon about, we have 14 standards, there should be one, so now there's 15. But no, Unicode actually was successful at kind of unifying the standards. But that didn't really have a huge impact on C++, at least not right away. So I'm going to introduce Tom, or allow Tom to introduce himself. And I'm going to ask you about what the heck is SG16, where did that come from, and what's your mission? Tom?
Uh-oh.
Tom froze.
It seems we just lost audio. Maybe it's coming back. Are we good?
I can hear you.
Yes.
All right. Excellent. We're good. So, hello, world. SG, I'll introduce myself first. I'm Honermann. I work for Synopsys on the Coverity Static Analyzer, where I've been there for, I think, coming up on 9 years now. I've been attending C++ committee meetings since Linexa in 2015. I think this last one marked my 11th meeting that I've been to. So it's been a good ride getting to meet all the experts out there and get to know them and make all the connections and getting to work with these great group of guys. So SG16. SG16 got its start shortly after the Toronto meeting in 2017, when myself and Zach and Mark Zarin, we got together, or sitting around thinking about Unicode issues and kind of wanting to do something about it. And we started informally meeting for a few months back then. And then in the Jacksonville meeting in 2018, Beeman Dawes encouraged us to form a study group, and we went to Herb and talked with him about it, and that ended up getting formalized then. And then we had our first meeting. Our first official face-to-face meeting was in San Diego in 2018, and I think we've met at every meeting since then. So good 5 or 6 meetings now. Meanwhile, we continue to meet about approximately bi-weekly via telecons, and usually have somewhere between 6 and 10 attendees. And we are working on a bunch of different issues, that some of which we've been able to land in C++ 20. But most are focused on C++ 23. We by the time we got started, there wasn't much runway left in C++ 20.
For 20, right. So let me ask you this. Obviously, SG16 is Unicode. Do you have a specific mission, or is it anything Unicode related, we want to chew on it in the SG16?
Well, we have a paper that discusses that. It is P1238. And so if you go and search for P1238 and SG16, you'll find it. And it lists a number of constraints, like things about the language that maybe we would like to be able to change, but don't feel that we have the flexibility to do so because of backward compatibility impact and things like that. And then it lists a number of directives for ourselves, to things to go fix and go change. So that's kind of, I think we'll dive into some of the details on that more a little later. But it's the paper's due for an update, which I hope that will get done for Varna, to focus more on C++ 23. But it kind of goes over the things that we would like to.
Right. I assume your mission evolves as the state of the language evolves. What your victories are changes what you start working on next. Does that make sense?
Yes, and it does have a scope section to it as well. Like our mission is really text processing. And so like text rendering doesn't fall under our scope. That falls more under SG13, the HMI group, to take care of.
Okay.
And same with like input devices or things like that. We're really looking at.
Sorry.
Peter, go ahead and introduce yourself. And
So my name is Peter Brett. I work for Cadence Design Systems, which is one of Synopsys's main competitors in the market. I've been working on electronics design software since, 2006 really, but I've only really been working in C++ since 2014. So I'm relatively new to C++ compared to many of the other SG16 members, but I've been wrestling with text and particularly translation in open source software for quite some time. That's my main reason for being interested in text. Now, one of the things I found really interesting when I started participating in C++ standardization was that SG16 is called the Unicode Study Group, but that's not really a good description for it. Really, it's coming to be the sort of clearinghouse for anything related to text or localization, really. And looking at the papers that are coming through in both Belfast and in Prague, and now I think people talking about bringing stuff to Varna as well, the remit really does extend well beyond just Unicode, and perhaps we should be talking about changing its name.
I think we actually are officially, at least in some of the documents, the text study group, not just Unicode.
Yeah,
Thank you,
sometimes
Steve.
we're Unicode, sometimes we're text, sometimes we're Unicode and text processing.
so Steve, go ahead and introduce yourself.
Okay. I'm Steve Downey. Work at Bloomberg. Been a programmer for about 30 years now. Here at Bloomberg for 17, where I do a lot of work with customer-facing communications, our customer-facing email and instant messaging system. So I'm on the bleeding edge, sharp point of the stick with dealing with text issues.
Sure. And Bloomberg's going to have customers speaking all languages. And
yes, and since nearly the beginning, Bloomberg has done a lot of work with localization and internationalization. It's like we want to sell to everyone and present their data to them and to everyone else. And that's hard because text is terrible. It's like we've had to, as you mentioned earlier, it's like with all the encodings, it's like, and although Unicode solves a lot of those problems, none of those encodings have gone away. All the data is still out there. People still exchange in various local formats. So it's like even on the web, it's like one of the first bits of information that goes across on a web page is what is the rest of this data encoded in?
And there are people actively working on things that are not Unicode?
Not so much actively working on. I don't think anyone is going to propose another encoding standard.
Well, I don't mean on the standard, but what I'm saying is, are there web pages out there that are?
Oh, yes. Yeah, actually, it's check that all the time, and also email. I've got to keep a report coming in of all the different encodings from internet email that come into our system, and there are a lot. They're also often wrong. The email will claim to be in one encoding, and parts of it may be, but other parts of it aren't. I think this is part of our remit. It's like we want to make it easier for C++ programmers to do the right thing and not have things broken by accident, which is the state of things today. If you're just dealing with a bag of bytes and you want to take a substring out of it, you've probably just broken things terribly.
Right. So we don't want things broken by accident. We want them broken
on purpose.
That's okay.
Yeah.
So Zach, do you want to introduce yourself and let us know about what got into 20 that was from SG16?
Yeah, so I'm Zach Laine. I'm a Boost author and a committee member, and I also work at Cadence Design Systems, just like Peter does, although we only know each other through SG16. It's a big organization with lots of moving parts. So one of the things that made it in was, we've got a lot of papers that come in front of us that are asking the question, they look at something like file system, they see there's all these interfaces that are WCHART, and there's all these other interfaces that are char, and what should I do in my library? What's the best practice now? And we've been trying to steer people in the right direction for that. So there's been a lot of stuff that has not made it into 20, but that is part of the 20 pipeline or 20 era pipeline, so stuff that started before we standardized 20, that we've been doing that with. One thing in particular that has made it in that's really significant is Tom's work doing char8t. So char8t is a new character type that is presumed to be UTF-8. And I was one of the people that didn't get this for a long time, and I think I finally understand this, and maybe I can explain it. If I'm wrong, Tom can correct me. But so the idea here is that if I have char8t, I can make overload sets that include char and char8t because they're different types that do not alias with each other. They're not type def with each other. You can effectively say, well, I've got this interface for people that want to truck in UTF-8 data, and I've got this other interface for whatever the platform encoding is. And so that lets you build those kind of interfaces.
So in other words, you have two types that all their properties are exactly the same, but they are distinct types. They are not a type def. One is not a type def of the other.
That's right. They're almost identical. They do have some different properties. I said on accident, I said the word alias, but that's because it was in my head, because one of the things about char and unsigned char is that they alias with other pointer types because of the rules of C++. Like, that's just the way they work. And so you get slightly more optimal code using char8t just because it doesn't alias with anything else. So that's one difference, for instance. Okay. So another thing that got in was Viktor Zverovich, who has the very nice FMT library, which became stood format. He got involved with us because he wanted to get the interfaces for format, the correct interfaces for format along the lines of which kinds of char interfaces to support and stuff like that. And I feel like we steered him in the right direction. And then towards the end, he said, we've got this, like width encoding. Or sorry, not with encoding, but with estimation we want to do for text. So when you print out text to a terminal, you say, like, I want to print like this with padding so that it's 8 characters wide. And so pad to the left or pad to the right or centered or whatever. And figuring out how wide a character is turns out to be best solved by using one of the Unicode algorithms plus a table lookup. And so we actually got that into the standard. So that is the recommended way of doing that. But because we understand some platforms are embedded, they might not want this table, they might not want the big heavy algorithm, so it might be just the estimated with this one. So it's implementation defined, but I know that Microsoft already has plans to support the Unicode, full Unicode version of things. And I don't know about other implementers, but they were very vocal in the room that that's what they're going to do.
So, so let me ask you about this now. So you're asking for the width of a string, or the width
That's
of...
right.
Okay.
That's right.
And,
so imagine
and this is the printed width. This isn't the column width, assuming one column per character.
That's right. Because
so we have to know what the font is, and we have to.
Well, we have
it starts to get sticky here because we have to have the notion of a terminal, but it's not really a terminal. It's essentially your FMT works on a format works on buffers of characters, and the buffers could be streamed out afterwards, and so then you have the notion of a terminal in the wording, but. Really, you should think of it as if I'm putting stuff in a buffer, I want the stuff in the buffer to fit, and there's like a maximum number of characters, of chars that you're going to write out into the buffer. So that's just to prevent buffer overflows and those kind of mechanical safety concerns, right? But there's a different notion of like, when I look at the characters that I put in the buffer in some kind of visual format, either in a terminal or I print it on a piece of paper or what have you, how wide are they? And typically, like if I print out foo, F-O-O, I'm going to get obviously 3 characters wide no matter what. That's always going to be 3 characters wide. If I print out F-O combining umlaut, so it's supposed to combine with the first O and then another O, that shouldn't be 4 wide, it should be 3 wide. And the reason is that there's a Unicode algorithm that says if I chunk up this string into characters, where a character is a loose term in all of Unicode, but in this case I mean technically an extended grapheme cluster.
A glyph,
right?
so to speak.
Almost. Because Unicode, almost.
So just to be clear, a glyph is something that lives in a font.
Right.
A grapheme is something that lives in Unicode.
Yeah. And a glyph does not correspond 1-1 to an extended grapheme cluster for a variety of reasons. For instance, you can put a combining umlaut and a combining circle and a combining bar and a combining little hat and a combining whatever. There's no glyph for that. But when you render it, you're supposed to put them all together in one character column. Okay, so the extended grapheme clustering algorithm says that's a width of 1 with all that garbage. Even though when you render it, it's going to look like nuts. You can't make sense of it, right? So anyway, that's because there is a good algorithm for this, a fairly stable algorithm called the grapheme clustering algorithm. And we said, hey, we should do what Unicode does here. And the reason is, if we don't do it now, even before that grapheme clustering algorithm is available for users as an algorithm in the standard library or something, if we don't do it that way now, people are going to come to rely on the columnar width of everything, and then we're going to be stuck forever. Mm-hmm. So that's an example of how, like, because of this study group, we've been able to influence some things so that we do them the right way the first time, which is mark it on your calendar because it doesn't happen that much, right? Usually something is subtly wrong with everything we standardize and we don't realize it until after the fact. And I think this is a good catch. I'm pretty happy that we got that done.
One of the other things that we influenced with format is making it locale agnostic for the most part.
Okay.
Which is subtle, but it's like people... Locale is terrible. We'll need to replace it eventually. But by default, format ignores locale unless you give it a locale or tell it to use explicitly the locale for formatting. So it's completely unlike I/O streams where someone changes the locale and suddenly your floating point numbers have commas.
So. This show is about giving people the opportunity to rant. Who wants to rant about locale? What's wrong with locale? Peter got his hand up first. So, Peter, you get to rant. What's wrong with locale?
Roughly speaking, everything. This is one of the weird things that I'm the most outspoken person in this study group about the need for localization facilities in the standard library. It's not an optional feature. But the problem is that the current std locale implementation, or I suppose implementation is not the right word, but what we've standardized in terms of locale isn't actually solving our standard users' problems.
What are the standard users' problems? What is it that we're trying to solve?
So suppose that I'm a German software engineer working in Germany, writing a software program for use by German users. I don't want to have to jump through a big pile of hoops to get my floating point numbers to turn up with commas as the decimal separator.
And that is the case?
At the moment, interestingly, we've made it too easy to step into locale land, right? We want to say, I want to be able to ingest my JSON from the web service, and then I want to use standard, i.e. American formatting of floating points when I'm parsing my JSON, because that is what JSON requires.
Mm-hmm.
And then when I'm displaying that data to a user, I want to use the language specific formatting that that user is familiar with. So the problem with the current locale system is that you kind of are a bit stuck. For most of the interfaces that we provide in the standard library, you have to say, this is the locale that I'm using on a global static variable.
Okay. So you can't say, I want to read this particular file with this assumption about locale, but write out to this particular file with this assumption about locale, which of course is something that is a quite plausible scenario.
Right, and to make matters worse, you can do that, but that's a thread unsafe operation to change that global thing.
That's correct.
So you can say, like, I'm going to set the locale read, set the locale something else, and write, and you're going to get data races.
To make things worse,
and just to make it more fun, since you mentioned locales and writing to a file, well, you have to have a way to name a file, right? Which means the file has a name, which, depending on how you look at it, has a locale associated with it, or doesn't, or has an encoding associated with it, or doesn't. So then it's just
and then to make things even worse, all of the locale stuff in the standard library is very heavily based on inheritance and virtual calls and allocating stuff into the heap with unclear lifetimes.
So it was state-of-the-art 1990s.
Yes, exactly.
I don't think it was actually state-of-the-art 1998, but yeah, it was state-of-the-art.
No, it was state-of-the-art around the mid-'80s when POSIX started working on it and got sucked into C and then into C++. And
it was one of those things. It was one of those things that got into the standard before Stepanov showed up and showed people how to write code in C++ at scale, right? I mean, like using templates for polymorphism at compile time instead of runtime polymorphism for anything. That was a change that happened after IO streams was kind of already solidified. So.
Okay.
And one of the big challenges here, of course, is that locale in many cases is a runtime thing.
Of course.
So you can't necessarily know all the information you need to generate your optimized floating point formatting code at compile time. You might need to have different code paths depending on what language the user would like you to use.
Right.
And there are facilities related to locale and standard library which are just unusable, like stood message, for example. So,
what is stood message? Or maybe we shouldn't even go there. Maybe it's just not is that too big a rant for?
The fact that you've never heard of it tells you what you should know about it.
Yeah, that's how much you should know about it.
All right. Okay. So this is history. This is the state. Locales suck. What are we doing for 23 and beyond?
Well, so John, this is actually a good place to inject something we talked about before the show, which is that part of the reason we don't have this stuff in C++ is that Unicode is just hard inherently. And the reason it's inherently difficult is that, you get the Chomsky hierarchy of languages. You've got regular languages at one end, you've got natural languages at the other. So natural languages are in some sense the opposite of regular. Right, they're the most anti-regular things you can have. There's all kinds of exceptions, or weird edge cases and oddnesses. And we've tried to take every known language and a few dead languages, and there's a user space where you can put Klingon and stuff. And we're trying to take all these possible languages, and we're going to make a small fixed number of algorithms that works for all of them. And it's literally impossible for some of the algorithms to do that. So there's a lots of the Unicode algorithms, and even in the Unicode standard, it'll say like, oh, this works except if you're speaking Greek. Then you need to add these exceptions if you really want it to work.
Give me an example of what you mean by a Unicode algorithm.
So the capitalization algorithm. Okay, so if you want to uppercase something, or better yet, if you want to title case something, you need a special algorithm for the Greek language because you use a different final sigma character if the thing is uppercase versus lowercase, but only if the sigma comes at the end. And there's a bunch of weird things like that. There's also an exception in Dutch as well. So the Unicode algorithm, as specified, says we know that we tend to target European languages first, but even these two major European languages, we don't support them fully. And here's how you can fix it if you want to fix it, but it's not part of the basic algorithm.
So does that mean that German? I mean, doesn't German have this delightful thing where there's a character that's a single character in capital but two characters in lower or something like that? I don't know.
Yeah. Yeah, so there's actually a special case for that as well.
But that's in the algorithm.
If I remember correctly, that is in the algorithm. I could be wrong about that. That might be one of the exceptions, but it's all listed in that document. There's another document about right to left versus left to right text, because you can have like left to right, embedded in right to left, embedded in left to right, embedded in right to left, up to 127 depth, which is completely bananas. But so if you have that, there's a bunch of cases that just don't work, and for that one, so I've implemented all these algorithms in this thing. I'm going to plug this for a second. It's a boost text. It's on GitHub. The reason I'm plugging it is not because I want everyone to know my name and use my library, but because this is the only large-scale implementation in a modern, range-friendly style, modern C++ kind of library of the Unicode algorithms. And so it is the closest thing we have to a path forward for standardizing other Unicode algorithms. So I'd really like people to get their hands on it, so I know if I've made a mistake, so that if I'm trying to standardize this stuff later, I get caught up.
So I'm seeing some nodding heads here. Is there some consensus on SG13 that this boost library is the path forward for C++?
We're programmers. Of course, there's not consensus.
Oh, okay.
I think
there's general consensus in the direction. There's not consensus on specific details that we need to work out.
So when I say that it's the only way forward, I'm not saying that it's the consensus way forward. I'm saying it's literally the only library I know of that's tried to do this. So it's the only game in town. So we may decide that we don't want to do this direction, but right now it's the only
it's
direction
the point about which we argument.
Yeah,
the basis of our argument.
Exactly. It's the only thing forward now to do all the Unicode algorithms in a modern style. That's all I mean by that. I'm not saying it's the right thing, but it's the default thing.
Is there any contention about that's what we want to do? Do we want all those algorithms in the standard?
I don't think there's any real contention on that. It's more the details. It's like what are the lowest units that we traffic in? Do we take in car data to transform it into something else, or do the breaking algorithms give you a text view, or do they give you graphene clusters, or a lot of details in naming things? I think we're broadly in agreement that we want something that looks like ranges. Just because ranges are awesome for dealing with these kinds of things.
Ranges are the future.
Algorithms.
Ranges are state of the art for 2020s.
Yeah, absolutely.
In 15 years, we'll be saying, what were we thinking with ranges?
Well, the thing is, in functional languages, lazy ranges have been a thing for decades, and they've been really useful. And we just only got them in 2020 and C++. So hopefully they'll be state of the art. They'll stay state of the art because they're a good idea. But so
they're fundamental.
I think where the most contention is, in my approach, is that I've made some very opinionated choices about simplicity, because as Steve was saying, we wanted to make it possible for people to do the right thing easily and not do the wrong thing by mistake.
Right.
So I'm trying to go in this radical simplicity route, and I know that was going to ruffle feathers, and it sure did. But so I made some choices, particularly with the text type. The text type being like a string-like thing that is Unicode aware. So it traffics in grapheme clusters instead of characters, and you can get code points and characters out of it at a lower level.
So go ahead, Zach.
Oh, so that's contentious because I picked a particular Unicode encoding. I picked UTF-8, and I picked a particular Unicode normalization, which is this thing called, I'm forgetting the acronym now. It's very close to FCC. Thank you. It's very close to NFC. So I picked those for technical reasons that I feel like are sound, but they're not the only choices, and it's reasonable for other people to want to do other things. There was even someone on the boost list when I brought up this the idea of getting this into Boost. Someone said well, I would never use this because all my data is not NFC, it's NFD, right? This other normalization form. So but I think the thing that is the most likely thing to be more or less unchanged that I've put in this library is to make the Unicode algorithms look like they do. So like Stepanov style algorithms with input iterators and output iterators, but in a range style. So you have the iterator based algorithms at the base, and then you have the range based versions, and you even have lazy ranges for most of them as well. So it's like the Stepanov algorithm ranges and view kind of triple that we expect from all our algorithms these days.
I see. Okay. So something we were talking about earlier, Peter, was kind of the difference between the data structure and how we conceptualize that. You were talking about the difference between a string and text. And I think for a lot of programmers, that's the same thing. But when we get into it, we have to just make a distinction. So what was the distinction you were thinking about?
So one thing that people think is a meaningful operation on a string, i.e. a vector-like collection of code units, is they think it's meaningful to substring it, to like drop the last 3 characters.
Okay.
I say characters with inverted commas here. When you go into Unicode land, that's a very debatable operation.
Because what it's a string of are not characters, but code points, which
Code
can
units.
combine into
Yes.
code units, which can combine into some human perceived character.
Yes.
Right.
So,
Your code unit is like a 1 octet of a UTF-8 sequence. And if you just take 2 of them away, you might have just chopped things in the middle.
Right.
But even if you avoid that, if you just took off the last code point, that might have been an accent grave, and now you're misspelling someone's name.
Right. So the things that we might normally think of, like, oh, I'd like to print this and it's too long, I'll just chop it here. It's kind of like deciding that your sweater's too long and we're just gonna snip off the bottom of the sweater. It's all gonna unravel. You
Yes.
don't have a nice, neat point where you can just chop it because of the data doesn't match data point to data point into characters, right? I mean, that's what we're talking about, because a string is a vector of data, where the data isn't a character that we perceive. Instead, it's something that maps, and possibly maps not one-to-one.
Yeah.
So the reason this is such a big problem in C++ is because, unfortunately, the C++ developer community is quite Anglo-centric. So when they do something like truncate a string by chopping off chars from the end of their std string, it works fine for them because they're only working with text that is in probably English.
Yeah. Cybrand just tweeted something, I think it was just this morning, about working on a team that's all English, and none of the code works in any non-Latin characters.
Yep. And Cybrand is in fact the person who is to blame for my presence in C++ standardization, by the way. So thank you.
So John, just a quick bit of terminology, because I know there's a lot of people that don't know the Unicode terminology. So there's 3 levels of sort of character data. Very loosely, character doesn't mean what it means. It doesn't mean char. In Unicode, it means a lot of different things, unfortunately. So the first level is like the code unit. And so let's say the example is UTF-8. So there's 1 to 4 code units that make up a Unicode code point. And a code point is like vaguely like a character, right? That you would think of. Like it's either a sort of a whole character you would see, or maybe it's a character that combines with another character, but it's a code point, right? So
it's a logical unit. It's
a
letter A
unit.
and the accent symbol. Those are both logical units, and each one has their own code point.
That's right. And
you could have the letter A with an accent unit, and that's yet a different code point.
Yes, and so that's an interesting thing. So you can have the 2 code point version, the A and the umlaut, or you can have the A with the umlauts, 1 code point. Okay. Unicode says, I don't care which form of that you have. If I ask you if those 2 are equal, you better say yes, because Otherwise, I can't reason about anything with regard to text, right?
So what that means is that I can't just, I don't know how to say this. I can't create an algorithm just mathematically compares two strings, character by character, or data point by data point, or whatever we want to call it, because there can be magical combinings that I can't mathematically derive. I absolutely just have to know this particular code, this accent can combine with this particular code, this vowel, but this particular code could never combine with M because we don't have an accented M, right? I mean, and there's no way to know this by looking at the code. You have to have a rule somewhere that's kind of an arbitrary human language rule.
That's right. And so strcomp and other essentially memory scrubbing simple comparison algorithms, like the way you would write operator equals for your simple string type that isn't Unicode aware, those are both too naive to ever work in a Unicode world. They're supposed to compare those two things as the same thing, only if they're in the same normalization form. Then they can do a strict byte-wise comparison. So we deal with these things called grapheme clusters, which are like the A with the combining thing, but I treat them as one thing, even though it's 2 code points. And those in turn might be multiple code units because it's encoded in UTF-8, right, or something like that. So there's sort of 3 levels of thinking about the data. There's the code unit, like individual data, individual one datum at a time, individual units of data. And then there's the code points that they comprise, and the code points also comprise grapheme clusters. And it's, you know, every time you talk about a Unicode algorithm to someone who doesn't know Unicode, everyone's like, "Why is this so stupid? Why is this so complicated? Why is this so hard?" and that's exactly the way I felt about it until I wrote a Unicode library. And I'm like, "Oh, it has to be this way because of reasons, because of all the stuff that has to happen to make the stuff work." And the reasons are as varied as they are boring to non-Unicode people, but they're there, and all the stuff is there for a reason, and all that complexity, unfortunately, you have to capture.
And some of those reasons that they're there go back to what you were talking about, John, earlier with the code pages and such, which are very much still alive and still a thing. But if you look at some of those code pages, they had single byte character assignments for like the A with the umlaut. And so for compatibility purposes, Unicode had to have a representation for that. But then they also wanted to be able to do the combining thing. Right. And so that legacy is what brought in this complexity that we have to maintain, even though we would love to move away from code pages.
Yeah, I mean, in Unicode, it's totally legal to write that M with an umlaut over it. That's well formed. There just isn't a...
There isn't any language that makes sense of that.
It's like,
no known words are spelled that way.
Heavy metal umlauts are allowed in Unicode.
Yeah, but your fonts will be very entertaining when you do things like that.
So,
but this comes up in normalization, like where they, as Zach was alluding to, it's like there's a whole database that says, oh, if you have an A followed by an accent grab, that combines together and maps to this particular code point. So when you're trying to decide, are these strings equal, you have to put it into one of the normalization algorithms, either a combined or completely decomposed form, so that you know that, okay, now I can do the bitwise comparison.
Okay. How much data is there to that? I mean, setting aside the algorithms themselves, I mean, if I were to write something and it had to include a Unicode library because I plan to, this is what I want to do. I want to read strings from files, so I can't pre-compute anything. I'm reading it from a file, and I want to compare strings, and they can be formatted in whatever way they're from different sources. How much data?
A lot, but less than you'd expect.
Yes.
And this has come up recently. We have a proposal for supporting named character escapes in the standard. So instead of like the \u NNNN, we want to do a \n and a brace and then a name for a character, because the code point value doesn't mean anything to somebody reading the code.
I see.
To give it a name.
That's really handy.
Yes, and it requires a database of names.
But that database could be known only by the compiler, right?
Yes.
Correct, which is still a concern for some people.
Yeah,
even
because
if
we
it is
want our
for-
compilers to be able to fit in 4K.
Yes.
Yes,
So-
currently.
Some people have distributed build systems where they ship around the compiler,
Right.
and believe it or not, the size of the compiler contributes to the latency involved in that and affects their build times.
Yeah.
So they
Some
do care.
people that are, let's say they're not frugal. I won't say which company is, but they're not frugal. They have a lot of money. Anyway.
So with this proposal,
But they want to be
challenged-
frugal with compile size.
Yes. We were
Compiler
challenged
size.
on database size, and so Corentin actually went and did some great work about how can we minimize this data. He has a wonderful blog post about it. And
So I should have directed the question specifically to you, Corentin.
Yeah, so actually I've done that work for code point names in both directions, going from name to code point and the other way around. That is about 250K for all the name, and obviously the name are the biggest database they have, right? Because name are maybe.
So by comparison, the rules that you would have to know that
So
these code points map to this, those are.
It really depends on the rule. Like so, some properties are like 1 byte for the entire Unicode database because there's like only one character that has that properties.
Oh, I see.
And some properties are maybe a few tens of 100K. One of the biggest database, for example, is what version each character has been standardized in, right? Because obviously you need that property for every character. So that's a bit big, but you don't use that often. So the thing you actually need, like capitalization, normalization, that's like not really big. It's not free, right? Because text manipulation is expensive.
So to give you one data point, my library has all the major Unicode algorithms in it. There's a few like sort of optional ones that I didn't do. To drive all of those, so there's more character data than you need strictly for the algorithms. But if you just want to implement the algorithms, the database I have is I think it's 2.1 megabytes as a shared library script. So that includes all the data and the code to access those data. The algorithms themselves are in headers, so they're not part of that number. So that's a rough estimate of how big it is. And I've done some work to get that smaller. In fact, I think it's an old number. I think it's maybe more like 1.5.
Yes,
but it also depends on the platform. It depends on the binary format of your SOs and all that kind of stuff.
But that also has a nice selfie of you in Hawaii or something like. No. That's just the data.
Yes.
Constructed from emojis.
I think that's bigger than I would have expected, but
yeah,
we're talking about all known human languages. So how many exceptions can there be, right?
There's a bunch of stuff in there that is used really infrequently, like Corentin said, but you need it in there for some of the algorithms. And so if you just restrict yourself to some subsets of the algorithms, the database is much, much smaller. In fact, one of the databases, the database for normalization, is literally inline in a header because it's small enough to fit in a CPP file. It's not a big deal.
Okay, we don't have a lot of time left, and I promised you all an opportunity to rant. Is there anybody who wants to rant about something that we haven't touched on yet?
I don't know.
Steve,
per se.
Rant away.
Okay, go ahead.
Well, no, I have bad news for everyone that we have a goal for C++ 23. We're not going to allow you to throw poo anymore.
Do you want to elaborate on this?
Yes, it's like we're fixing it. This came out of a defect report against C++ 20 and earlier. The characters that we allow in identifiers are a mess. We didn't know what we were doing back in '98 and allowed all sorts of things that are just terrible. Things like left to right modifiers. So someone could stick a left to right modifier in an extern symbol, and then your stack trace is going to come out backwards. It's no fun. Fortunately, since then, the Unicode Standards Group has published a pretty good technical specification about what things are allowed in identifiers. Things that look like words. Emojis don't make the list.
So are emojis in the Unicode standard then?
Yes, it's like they're the ones standardizing all of the emojis, and Emojis are very complicated to process. Poo isn't too bad because it's just one, but as soon as you now have
modified by skin color or any of the other things that emojis have to be,
genders and zero width joiners and flags and how they work, it's all very complicated. And when the Unicode Consortium says don't do that, it's probably a good idea to listen.
So right now, so this is one of the things that I actually do for conference work is when you make a submission, if anywhere in your title or your abstract you use angle brackets, which of course people do all the time because they're saying, you know, here's this example of template code or here's something like that. What I do is I process that and replace it with what are full width less than and full width greater, something like that, that look almost the same to humans, but they're processed differently. So they're not, because the problem of course is if I take an abstract and then I push it to something like sked.com, it's going to see those angle brackets as some kind of HTML thing. And of course it won't find the tag. It'll just ignore it. And so people reading the abstract are going to say, what are you, this is nonsense. It doesn't make sense. So, but what that means is someone, not like an innocent person like me, but somebody might create an identifier in C++ with a full width less than or greater than, and someone reading the code might not appreciate that that's not actually an operator that the compiler is going to see and process, and instead is actually just the name of a variable or type or something like that.
And in fact, a lot of those got eliminated. All the things that are in the list of allowed characters look like letters, basically.
So aren't you worried that that might break existing code?
Considering how hard it is to write Unicode in C++, not really.
Oh, okay.
So we like to joke a lot that
and GCC 10 is going to start allowing UTF-8 as an input. So this is something we want to get ahead of a little bit.
I see.
But yeah, right now, no one, you would have to write /u number and deliberate. Basically, it shows up in people's unit tests.
Well, or in tweets. So we're breaking a lot of tweet code.
Yeah.
Yeah.
Oh,
So
yeah. We're going to break all your slideware.
this is one of those situations where, yes, we know that there is potential for breakage, and no, we do not care at all. Like we just don't care about the poo exception.
The argument being made is any code that's broke is already broken.
Yes.
Yeah. And Steve's shirt illustrates this exactly.
Yeah.
All right, so
But
you're
you
going to read that
stand
to
up
us,
all the way
Steve,
so
because
we see the-
not everybody's going to see this on video. But you have this is actually a picture of a tweet that you made. Is that what it is?
Yeah. Unfortunately got a little ahead of my wife made the T-shirt. In Belfast, EWG had forwarded it to Core, and we were all like, yes. And then on the mailing list, Core said, we've got some questions, so we're going to be discussing it a little bit more in Varna. But essentially, it's like Core said, well, how are you addressing the preprocessor? And we're like, why do we have to address the preprocessor? And
Okay, so what your shirt says is the shirt is a picture of your tweet in which you said, it's my fault you can't throw the poo emoticon anymore. Semicolon. Okay.
If you listen to the podcast, I'll put this in as a chapter art at this point.
There you go. And then underneath on your shirt, it says, sorry, not sorry.
Not sorry.
So in other words, if we broke any of your code doing this, you had it coming.
Yeah. It's like, you should have known better. It's like,
You should have known better. Your coworkers are not appreciating your Unicode puns in your code.
And to put the more serious side to it, part of the motivation of this is security concerns, right? You can imagine a pull request to an important code base, where if you read the code, it looks perfectly fine, but the fact that identifiers that look exactly the same are not the same identifier
because of some zero width character that's been inserted or something like that.
Exactly. Like there's some real potential for abuse there.
And unfortunately, there's also, this is where normalization comes in again, because you can have A with a combining umlaut or the A with an umlaut. Those should be the same thing in terms of when I look at it in my editor, I see the same thing. So they better be the same identifier. And the state of affairs before Steve's paper about this was that those were actually different. even though in your editor they looked identical. You could have a umlaut, auto a umlaut equals 1, auto a umlaut equals 2, and that compiles and links and everything's cool. So that shouldn't be.
Speaking of Twitter, for those of you who are not watching but are only listening, Zach's been live tweeting this entire show with a little friend in a cage behind him there. There you go. Hello, little friend. So we're kind of at an end here, not because we've run out of things to talk about, but because we've run out of time. Yeah, it's been an hour, and it's been a great hour. It's been a lot of fun. I hope you guys got as much chance to rant as you needed, because I mean, whoever gets enough chance to rant. But we do want to wish everybody at home safe coding. So please join me and say to everyone, safe coding.
Safe coding.
Safe coding.